Alright, for sure. So I'm going to try to explain problems 4, 5, and 6. Okay, so in problem 4, they tell you that you're in an elevator, right? And it's moving in a constant speed. And the mass of your individual is 80 kilograms. And the first thing that I did was I drew what I got. I drew a diagram. So this is my elevator. I know it's a ghetto elevator, but whatever. My person, I made him the circle. I circled him because I was going to do that for the vector sum diagram, and then I labeled him 80 kilograms, and I wrote some stuff, probably, I don't know, labeled it, right? So the next thing I did was that I did the vector sum diagram, right? And there's only two forces acting on this system. It's only gravity, which we already know, the variable is defined, it's 9.8, right? And I just put it to 10 newtons, and the upper arrow, which was the force of the elevator pulling you up or acting upon you, right? So in this problem, there's only one thing that you could really solve for. There's not much that they give you, so what you can solve for is weight, right? So you go down here, and you go to weight, and you know that weight equals like your mass times whatever this is in newtons. So I did that at 80 kilograms times 10 newtons. You can't really see it, but whatever it is. 1 kilogram, and then you want to get into newtons, so you get 800 newtons. And that's pretty much all you pretty much get for the first problem. Alright, for sure. Now for problem number 5, it's pretty much the same thing. You have the same elevator, you're in an elevator, the same person weighing the same thing, 80 kilograms, but they change it up on you a little bit. The only thing that changes was the fact that you're not moving at a constant speed anymore. You're accelerating in the you're accelerating upwards at a rate of 3 meters per second squared, right? And so what you do here, what I did here, was I drew my vector sum diagram. It's cut off a little bit, but you know, I do what I can. You have the same things acting upon each other, right? You have gravity, which is already defined. We already established that up here. It's 10 newtons, right? But what changes this time is that this section of the vector sum diagram. You can't really see it here, but this part is definitely longer than this part. Is longer here than it was here, as opposed to these two being relatively equal. Okay, so yeah. So the fact that we have an acceleration means that we can find the net force, right? Okay, so to find the net force, the first thing that I did was I drew a vector sum diagram. Again, I'm sorry, you can't really see it, but this is the force of the elevator, right? And then I drew the force of gravity, the little tail right here going to the head down, right? And as you can see, this one, which is this one, is longer than this one, and you need to find this. And when you find this, that's your net force, right? And your net force is pretty easy to solve. All you pretty much have to do is multiply your mass, which in this case is 80 kilograms, still 80 kilograms, and your acceleration, because net force equals mass times acceleration. So you do that, you get 80 kilograms times 3 meters per second squared, and you get 240. And like I talked about this in the last video, kilograms times meters per second squared is newtons, so you just get 240 newtons, right, for your net force. Okay, and because we had already established the fact that actually, no, never mind. I'm getting myself confused. Because we already established the fact that weight of the object was 800 newtons, you make this equal 800 newtons, and this just seems to be a miscalculation. It's probably supposed to be 560. 560 plus 240 is 800. And I think I just wrote it down. That was confusing. Okay, so that's pretty much it for problem 5, so I can find. Now we can move on to problem 6. Problem 6 is very similar to problem 5. Because you need to find the net force, but the wording of it is weird. Okay, so it's the same system, same object, same person, same elevator, same mass, and everything. But the difference is that it's not constant anymore, it's not accelerating upward, it's moving up and slowing down, right? So the only thing that you have to do is you draw the vector sum diagram, right? Because it's moving up, you still draw this part of it, but it's slowing down, so the force of gravity is supposed to be bigger than it. So you can see that in my vector sum diagram. This is the force of gravity, right, which we already established was 800 newtons because of the weight. And this is our system, or whatever, the person. And it's the same thing as this problem. You do the same things. but instead of the larger number, instead of the force of this object right here being 240 as it is in this side, it's reversed because it's slowing down, right? So it's just, you do the same thing you did down here, you do all the calculations, but you already know how to do it. Net force equals mass times acceleration, right? And then, yeah, so you do that, and then this will be 540, that will be 240. I mean, 560, this will be 240. And this will always be 800 newtons. And yeah, I'm done.